In this lesson, we're going to look at multi-stage experiments and expected value. Our objectives: understand how to use multiplication rule in multi-stage experiments. Basically, we can take the branches of a tree diagram and use multiplication to see the probability that the end branch of those options happening. Number 2, understand how to find the expected value. When you're dealing in certain situations, you can find, say, the expected age of a person with certain data. Vocabulary is pretty simple. Independent. Occurrence of one event has no influence on occurrence of another. So basically, it's kind of like flipping a coin. If you flip a heads on the first time, that's not going to affect the second flip. Just because you flip a heads the first time doesn't mean that heads is less likely the second time. Dependent. Probabilities are influenced by the outcome of previous event. So when we do, if something goes good or bad, that actually affects the possibility or the chances of it being good or bad the next time. So that's what dependent versus independent are. The first thing we're going to look at is a multi-stage experiment. So what we're going to look at is rolling a die twice. So basically, if you take a die and you roll it, you're going to have certain outcomes. Well, in the first situation, we're going to look at two possible outcomes: a perfect square or a rounded square. Basically, what I mean by that is a number that is a perfect square. Well, there are two options on a die, on a six-sided die. One is a perfect square, or 4 is a perfect square, meaning that we have a possibility here of 2 out of 6, or 1/3. A rounded square would be anything that isn't a perfect square. So here we have 4 options. We have 2, 3, 5, and 6, which is 4/6, or 2/3. So that's the possibilities on the first roll. The second roll, we're going to be looking at things differently depending on what the first roll was. So for roll 2, if we got a perfect square, we're going to just look at even or odd when we roll, meaning we're going to have even options of 2, 4, and 6, giving us 1/2 for a probability there. And odd, we have 1, 3, and 5, again giving us probability of 1/2 for those situations. If our outcomes were rounded the first time, then we have 3 things that we're going to look at here. One is a unit. Well, unit is just one number. It's 1. So there's a probability of 1 out of 6 for that. Prime, we're looking at prime numbers. We have 2, 3, and 5, which are prime numbers. So that's 1/2, or 3 out of 6. And composite would be our typical composite numbers. 4 and 6 are the only ones left there. So that would be 1/3. 2, 6 becomes 1/3. Okay, so we're going to use these numbers to predict the likelihood of different pairings. So here I've already drawn out our tree diagram. Probability of a square is 1/3. Probability of an even number is 1/2. So the probability of S and E, so a square and even, in our two rolls would be that we multiply these two together, which is 1 over 6. Odd is 1 over 2 here, so we've got 1/3 times 1/2, we get 1 over 6 again. 1 over 6 again. Here we've got probability of round, which was 2/3, and probability of unit. Unit was 1/6. So we'll put a 1/6 here. We're going to multiply these. We're going to get 2 over 18, which is 1/9. Okay, then the next one, probability of a prime is 1/2, which is going to give me 2 over 6, or 1/3. And our last one is P of C, which is composite, which is 1/3. And we multiply, we're going to get 2 over 9, which is just 2 over 9. Now, one of the important things here is these are all our options, so all these fractions should add up to 1. Well, 1/6 and 1/6 make 2/6. 2/6 is 1/3. 1/9 and 2/9 is 3/9, which is 1/3. And then we have 1/3. So this is going to add up to 1. So it works. What we can do is we can say that the probability that you're going to roll a square followed by an even is 1 out of 6 rolls. Alright, now we're going to move on to expected value. So for expected value, what you need is data. Here what I have is puppies in a litter. So all the dots represent dogs that had litters, and then the numbers represent how many dogs were in that litter. And we want to know how many dogs we should expect in any litter that we have at this dog kennel. So having 2 puppies, well, that was 4 out of, there's 4, 10, 8, and 3. So this is out of 25 for a total. So we got 4 out of 25. Here, 3 puppies, we had 10 out of 25. 4 puppies, we had 8 out of 25. And 6 puppies, we had 3 out of 25. Well, then what we do is we take the number times the probability to get our product. So we're going to take 2 puppies times 4/25. And we get 0.32. Then we're going to do that 3 puppies times 10/25, 4 puppies times 8/25, and 6 puppies times 3/25. And we'll have the products for each of these. $1.2 here. $1.28. And our last one is 0.72. So now what we do is we add all these together, and that's what our expected value or expected number of puppies in a litter would be. So we're just going to go 0.32 plus 1.2 plus 1.28 plus 0.72, and we get 3.5. We get 3.52. So a baby in this, or a dog in this kennel, a female in this kennel, we can expect them to have 3.52 puppies when they have a litter. Now we all know that you can't have 0.52 puppies, so our expectation is that the dog is either going to have 3 or 4 puppies in their litter based off of these numbers. Alright, in this video we've learned how to find multi-stage event probabilities and find the expected value in an outcome. If there's any part of this that you didn't get or you need to watch again, make sure you pause, rewind, and rewatch, and bring any questions to class. Thank you.